All right, let's talk about one of the most common and, let's be honest, frustrating issues you're going to run into with Delta CP2000 drives, that dreaded oH1 fault. If you've ever seen it, you know it means your production line is down. So today, we're going to figure out how to tame that fever for good.
Okay, picture this. You're on site, the whole operation's at a standstill, and you look over and see this code flashing on the drive's keypad. Your heart kind of sinks, right? But what if you knew exactly what to do? That's what this is all about. We're going to build a step-by-step game plan to get you back up and running fast.
So what's the drive actually trying to tell you? Well, oH1 means IGBT Overheat. The IGBTs are kind of like the heart of the drive. They do all the heavy lifting, the switching, and they've just hit their thermal limit. We're talking 90 or 100 degrees Celsius. The drive is basically screaming that it has a fever, and it's shut itself down to stop from cooking its own hardware. It's a safety measure.
To figure out why it has a fever, we first got to understand how the drive breathes. Yeah, you heard me, breathes. Think of this as a quick look at its anatomy, because once you understand the system, the solution becomes obvious.
This right here, this shows you the drive's entire cooling strategy. It's all based on something called the chimney effect. Super simple. Cool air gets sucked in from the bottom, that's the inhale. It flows up across the hot parts inside, and then all that hot air gets pushed out the top, the exhale. Here's the golden rule. Anything that messes with this simple up and down airflow is what's going to trigger that oH1 alarm.
So, if airflow is the key, what could possibly be going wrong? We're going to tackle this like a doctor trying to figure out a mystery illness. We'll do a differential diagnosis, checking off the possibilities one by one till we find the real root cause.
And here they are, the 4 main culprits we need to hunt down. Number 1, environmental stress. Basically, the room is just too hot. 2, suffocation. Something's physically blocking the air vents. 3, crowding. The drive is choking on its own hot air. And number 4, organ failure. Yep, the fan itself might just be dead.
Okay, let's start with the easiest and most common stuff first, the environment around the drive. This should always be your first step.
First step, let's check the patient's vitals. But here's a pro tip, and this is where a lot of people go wrong. Don't just check the temperature of the room. The air inside an electrical cabinet is almost always way hotter. You have to measure the temperature exactly 50 millimeters, about 2 inches from where the fan sucks air in. If that air is over 40 degrees Celsius, well, the drive is trying to cool itself with hot air. It's a losing battle.
Next, look for what I call crowding. You see what's happening here? The hot air being blown out the top of one drive is curling right back around and getting sucked into the bottom of the drive next to it. It's a vicious cycle of overheating. This air recycling is a silent killer for VFDs. The fix is actually pretty simple. Just install some physical barriers or little deflectors to make sure that hot exhaust gets sent away.
And to stop that crowding in the first place, you've got to follow the doctor's orders, the manufacturer's prescription for spacing. Now I know it's a table with numbers, but the key thing to remember is this. These are the absolute rock-bottom minimums. If you've got a cabinet that's jam-packed with stuff, you're probably going to need even more breathing room than this.
All right, now we check for suffocation. Take a good hard look at the bottom intake vents. Are they fuzzy, caked with dust and grime? If they are, that is a huge red flag. It means the heat sink inside the drive is probably clogged up too. Think of all that dust like a big warm winter blanket trapping all the heat inside. And trust me, a few minutes of scheduled cleaning is way cheaper than hours of unscheduled downtime.
So, if you do find it's clogged, here's how you treat it. And listen to me very carefully on this. Step 1 is not a suggestion, it's for your safety. Power off the drive completely. And then wait. Wait until that display is totally dark. That's how you know the capacitors inside are discharged. Only then should you take the cover off and blow it out with compressed air. From the top down, the same way the air is supposed to flow.
And please pay attention to this next part. This is a pro tip that can save you from a repair that is way more expensive. When you use that compressed air, take a little screwdriver or a zip tie and physically stop the fan blades from spinning. If you let that air spin the fan like a pinwheel, it acts like a little generator, sending voltage backwards into the control board and poof, You can fry it. Seriously, don't do it.
So what if you've done all that? The air is cool, the drive has plenty of space, the heatsink is sparkling clean, but you're still getting that O1 fault. Well, now we have to consider the last possibility. It might be time for surgery. We're talking about organ failure.
The organ, of course, is the cooling fan. But hold on, before you assume it's broken, you gotta check one thing. Pop into parameter 0719. Some settings only kick the fan on when the drive is running or when it gets hot. But if that drive is faulting out with an oH1 and that fan is definitely not spinning, well, it's time for a transplant.
Now the good news is, for the smaller drives, the frame A through C sizes, this surgery is super simple. It's a neat little modular design, no tools needed. You just press the tabs on the side, unplug the little power connector, and the whole fan assembly just pulls right out. Easy. Now let's see how it's a little different on the big guys.
I'm going to pause here because I can't say this enough. This is the most critical step of the whole replacement. You absolutely must unplug that tiny power connector before you try to pull the fan out. If you just yank on it while it's still plugged in, you're going to break the connector right off the main circuit board, and you've just created a much bigger problem.
For the bigger drives, frames D through H, it takes a little more work and a screwdriver. You'll have to loosen the top cover to get access, disconnect the power, and then loosen 4 screws holding the fan in place. And just a little note from the field, these fans are surprisingly heavy, so make sure you're supporting the weight when you take those last screws out so you don't drop it.
Okay, the surgery was a success. The drive is back up and running, but we're not quite done. Now that we've fixed the immediate problem, let's talk about keeping our patient healthy for the long run. Let's talk prevention.
You know, some drives just have to live in tough neighborhoods, like a hot boiler room or inside a metal box baking in the sun. For these chronic conditions, you have to manage them. The rule is simple. If you can't lower the heat, you have to lower the load. We call this derating. For every single degree Celsius you go over that 40-degree limit, you need to reduce the drive's output current by 2%.
And here it is, your final summary, the doctor's checklist. Every single time you see an oH1 fault, just run down this list. Is the air temperature at the intake below 40 degrees? Yes. Are the clearances good? Yes. Are there barriers to stop recirculation? Yes. Is the heatsink clean? Yes. Is the fan spinning? Yes. If you can check yes on all of those, your problem should be solved.
And that's really what it all comes down to, isn't it? The health, the long life of your drive, your system's uptime, it all boils down to this one simple principle. So the next time you see that oH1 fault, don't panic. You know the drill now. You've got the checklist. The only question is, will you start using it for your preventative maintenance before that next fever strikes?